Hi, I am Jessica McClellan, and I'm going to be doing a problem from Chapter 19 of Confidence Intervals for Proportions. Alright, so our question that we're going to do today is over here. A recent study of 3,200 college students randomly selected found that 19% of them are binge drinkers. We're going to try and construct a 98% confidence interval for the true proportion of students that are binge drinkers. Okay. So the first thing you need to look at before you get started on trying to find the confidence interval is you're going to have to look at the underlying assumptions. These are all going to have to be met before you go ahead and try to do your confidence interval. So you need to go ahead and see if the independence condition, the randomization condition, the 10% condition, and the success-failure conditions are met. Alright, so the first step you want to do is to tackle this problem, you got to know the equation. So the equation that we use to find the confidence intervals is this looking thing right here. And this may look a little scary, p hat plus or minus z star times se p hat times p hat. What the heck's that mean? Alright, well I'm going to explain that and break it down to you. Alright, for our equation, p hat that I just said is the sample proportion from the problem, which in our problem it's going to be the 19% of them are binge drinkers. Is critical value is what we'll get into later, and we're actually going to use a table to find that. And then SE times P hat is actually, you're going to be finding the standard deviation of the proportion, which is found and estimated through another equation, which is right here. It's going to be square root of P hat times Q hat over N. And N just means the sample size, so in our problem it's going to be the 3,200 college students, and then Q hat is just found from 1 minus P hat. So alright, we'll go ahead and get this started. Alright, so we're going to go ahead and tackle this problem here. We're going to go ahead and do the standard deviation of proportion by this equation, P hat times Q hat over N. We're going to go ahead and find Q right away here. And so we'll go in here. Our p hat from the problem is 1 point. We're going to put this into a decimal form. So all of our percentages. So for 1.9 minus 1 minus 1.9. So that's going to equal 8.1. So we're going to enter this into our problem. P hat times Q hat over our sample size here, 3,200, which is going to equal the answer that I got is 0.0069349. For this, we're going to round to the third decimal, so I'm going to go ahead and round that to 0.007. And we're actually going to be using this later into the problem, so we're going to hold this out to the side here. 7 SEP equals 0.007. Because we're going to have to enter that, plug it back in. Alright, so we found the standard deviation of proportion, and our next step is going to be trying to find the margin of error for our 98% confidence interval. So what the heck does that mean? Well, when you look at what we're trying to find is the 98%. So this is the 98%. So this whole graph thing right here is 100%, but we're only going to be finding that one side over here. So that's just that 1%, meaning that everything else is just normally distributed. So how we're going to find the z-score in our equation of ME equals z critical value times SE, which is our standard deviation of proportion. We're trying to find this number right here. So this is where the z-table comes into place. And what we're going to do here, since we're going to be technically going to be finding the 99%, we're going to come into our table and find the area that is closest to the decimal of 99%. So we're going to look all around in this area, which we already found right here is the closest number. We found 0.9901. And if you look closely, you can see the z-score out here on the side of the table. So you'll come to this number right here and drag your finger across and this will also give you a number up here. So that means that our critical value is going to be 2.33. Alright, so now since we found our critical value, 2.33, we can plug it back in. So here's our margin of error we're going to be finding. ME equals 2.33 times the number that we found earlier here. That's where we're going to plug it back in. Alrighty, we go ahead and plug that back in. Work out real nice here. So I get the number of 0.0161, and we're also going to round to the third decimal place on this number as well. Alright, so now, to finish out, to get our confidence interval, we're going to come back to our p-hat over here. So we're going to take our p-hat, let me get a new marker. We're going to take p-hat plus our minus to get our upper and lower confidence intervals, plus or minus our ME, which is this number we found right up here. So we're going to do 0.19 minus 0.016, and then 0.19 plus 0.016, and this is going to get our confidence intervals here. So for our lower confidence interval, whoops, it's not doing 0.19 minus 0.016 is 0.174. And our upper confidence interval is 0.19 plus 0.016, 0.206. So these are our confidence intervals, which means that we are 98% confident that between these numbers right here, we will find our true proportion. Thanks. That's your answer.